So again, we're looking at solving polynomial inequalities. In this case, we are given a table, but it's the same 4 steps. We're going to identify our roots. We're going to look at our y values to identify the pluses and minuses. We're going to shade our number line, and then we're going to write our domain. So the first step is identifying the roots. Remember, in a table, the roots are anywhere y equals 0. So we're just going to go through and circle every single time y equals 0. And just so happens x and y equals 0 right here, but I'm looking for the y, not the x. So how many do we have? I got 4 of them. I'm going to go ahead and put those on my number line from left to right. I'm just going to evenly space it. So my first one was at -5. The next one's at -2. Then I have 0, and then I have 3. Okay? So now let's figure out our signs. So for the signs, we look at our y values. Okay? So for our y values, this 7,000 is negative. The 392 is positive. The negative on the 64, positive on the 72, and positive on the 1400. Now we can translate that easily to our number line. So -7, that x value would be right over here on the left side because it's going to negative infinity on the left. So my negative sign is over here on the left. Then between -5 and -2, we put a plus sign. Between -2 and 0, we put another negative sign. And then between 0 and 3, we have a plus. And then after 3, we have another plus, and that's going to positive infinity. Now that may look a little weird, so let's just look at that. Notice they alternate negative, positive. I should have written that down there. Oops. Negative, positive, negative, positive, positive. So the fact that I have 2 signs that are same means this is a double root. Both signs are the same. It could be 2 negatives or 2 positives, but if there's 2 of them back to back, they're the exact same. All right, so now let's look at what kind of dots we need to draw for this one. So notice I have an equal sign for both my greater than and less than. That means I'm going to have nice solid dots on every single intercept. So let's do our less than parts. So we're going to come in and we're going to shade our negatives on this line, just to mix it up a little bit. So for our negatives here, where we're less than, let's write our domain. So we go from negative infinity to -5. Oh, but it's a solid dot. So we're going to have a bracket. Then we have a U, and we go from -2 to 0. Notice all the numbers have brackets because every single one of them have a solid dot. Now let's look at our positive values. Okay, so also equal. So we're going to go from -5 to -2, brackets on both because they're solid dots. They're equal to 0. But now we have the quandary. Do I go from 0 to 3 and then 3 to infinity? You could, but it's equal to 0. And right here at 3, it does equal to 0 in my table. So because it is equals, I can combine these 2 sections together. They are right next to each other, so I can go from 0 all the way to positive infinity because that whole area satisfies greater than and equal to. So now let's look at what our equation would look like. Same thing, we're going to change the sign. So I have an x plus 5. -2 becomes x plus 2. The 0, remember we don't have to write it. We could just write it as plain old x. And then I have x minus 3. But we labeled it as a double root, so we have to square that one. On the right-hand side, it goes up. So we just put our y equals in the front, and we don't have to worry about putting a negative sign. Awesome job.